Hey, good people, welcome back. I hope that all is going well. This is Arthur Morris. In this video, we're going to look at how to solve systems of nonlinear equations. So a system of nonlinear equations in two variables can also be called a nonlinear system, which means that those equations, if we were to graph them, would not create straight lines. So a solution of nonlinear system in two variables is an ordered pair of real numbers that satisfies both equations in the system. The solution set of the system is the set of all such ordered pairs, which means you could have more than one solution. So the first method that we're going to look at is the substitution method, solving by the substitution method. So we can use the substitution method uh, when one of the equations uh, has a variable with an exponent of 1. So it says the substitution method involves converting a nonlinear system to one equation and by one variable. The steps in the solution process are exactly the same as those used to solve a linear system by substitution. Since at least one equation is nonlinear, you may get more than one point of intersection, as you can see below. Right, so let's say we have a system x squared plus y squared equals 109, which is a circle, and x minus y equals negative 7, which is a linear equation or a straight line. And let's do it like we did it before. Let's call this equation 1 and that one equation 2. So to use substitution, you need to solve one of the equations for a single variable. Now, since the variables in my second equation have the exponent of 1, that's the equation that I'm going to use. I'm going to solve that second equation for x. So now I'm going to rewrite equation 2. I'm going to add y to both sides. So equation 2, positive y minus 7 by adding y to each side of the equal sign. Now what that allows me to do is to take that information and substitute in for x in equation 1. Since x equals y minus 7 from equation 2, I can replace x in equation 1 with y minus 7. So instead of x squared, I would have y minus 7 squared plus y squared equals 109. Then from here, we want to multiply y minus 7 squared out. Binomial squared. So first term squared, y squared minus 2 times 7 times y plus 7 squared, which is 49. And then don't forget the plus the y squared equals 109. Okay, combining like terms, you see I will have 1y squared plus 1y squared on that left-hand side, which is 2y squared. Therefore, I have a quadratic equation here, which means I need to have all of my terms on the same side of the equal sign. So I'm going to subtract the 109 over. So if I combine 49 minus 109, that's negative 60. All right, so I see 2 will go into all of those terms, so I'm going to factor out a 2. And then I need to factor the trinomial. I need to find factors of negative 30 that gives me a sum of negative 7. So how about negative 10 and positive 3? All right, set our variable factors equal to 0 and solve. Therefore, y equals positive 10 or y equals negative 3. So we have two different y values, which means we probably have multiple places of intersections. So we need to find the x coordinates that go with these y coordinates. So if y equals 10, then using equation 2, where I've already solved for x, that tells me that x is equal to 3, or the ordered pair 3, 10. Now you can check that back into equation 2, and as a matter of fact, or equation 1, since we use equation 2, check it back into equation 1 and make sure that it makes a true solution. 3 squared is 9 plus 10 squared is 100 equals 109. So that makes a true solution, so we know that this is one of our solutions. How about when y equals negative 3? Well, using the modified equation 2 again, we get 3 or negative 3 minus 7, which is negative 10. So when that gives us the point negative 10, negative 3. And again, I would encourage you to check it back into the other equation since we use equation 2 to find the values. Check those values back into equation 1 to make sure they make a true statement. Alrighty, let's look at another example. Okay, so here we have x times y equals 40, or the product of two numbers equal 40. X times y equals 40. And then the difference of 2 times a number and the other number equals negative 2. So 2 times x minus y equals negative 2. So again, you want to solve one of these equations for one of the variables. So I'm going to solve equation 1 for x. So to solve for x, since I have x times y, that means I need to divide both sides by y. So that means x equals 40 divided by y. Now again, what that allows me to do, it allows me to take that information and substitute in equation 2. Replace x with 40 divided by y in equation 2. Alright, so 2 times 40 divided by y minus y equals negative 2. So multiply to clear the parentheses. Here we need to multiply both sides by y to clear my denominator. So distribute on the left-hand side of the equal sign. Which gives us 80 minus y squared equals negative 2y. So we have a quadratic equation again because of that y squared. So that means we need all of our terms on one side of the equal sign. So I have negative y squared. I need to add 2y. And then my 80 was positive, and it was already on the left-hand side, so it keeps that same sign. All right, now, we really don't like to leave that leading term as being negative. So I'm going to multiply both sides of my equation by negative 1, which essentially just changes all the signs. So we have y squared minus 2y minus 80 equals 0. So we're back down to that good old factoring. So we need to find factors of negative 80. That gives us a sum of negative 2. That's right, negative 10 and positive 8. Set your factors equal to 0 and solve. So we see that y equals 10, y equals negative 8. So just as we did with the previous problem, we need to find the x coordinates that go with each one of those y coordinates. All right. So I'm going to use the modified equation 1 where I've already solved for x. So when y equals 10, x equals 4. And again, since I use equation 1 to find that value, then if I were you, I would take those values, plug them back into equation 2. 2 times 4 is 8, minus 10 equals negative 2. It checks out. So this is a solution. Now how about when y equals negative 8? Then x equals negative 5. All right, so if I check that back into equation 2, 2 times negative 5 is negative 10, minus negative 8, so plus 8, so negative 10 plus 8, it's negative 2 as well. Checks out. Those would be my two solutions. Alrighty, good people. I hope you found this video to be helpful. I will see you on the next one. Thank you.